Hi, I'm Zhiming, a postdoc from Dr. Sarkar's Environmental Sustainability Lab. One of our research projects is the remediation for lead contamination in soil, particularly in residential soil. Lead contamination is a major issue for residential soil around older buildings where lead-based paint was used before. In some cities in the US, more than half of the existing housing facilities were built before the lead-based paint was banned in 1978. Since lead can persist in soil for a long time, concern about human exposure remains despite the ban was effective more than 40 years ago. Lead-contaminated soil and dust are poisonous for humans, especially for children under 6. Our research team performed an extensive field survey for various residential sites in several cities, such as San Antonio in Texas, Baltimore in Maryland, and Jersey City in New Jersey. Results show lead concentrations are as high as around 4,200 ppm, which is far more than the EPA soil lead hazard cutoff value of 400 ppm. To deal with the lead contamination in soil, we utilize phytoremediation, or specifically phytoextraction, that extracts lead by hyperaccumulating plants. We tested a hyperaccumulator, vetiver grass, to extract lead from soil under controlled laboratory and greenhouse conditions. Vetiver is a tall and fast-growing grass with a massive and complex root, which is favored by phytoremediation. Vetiver's dense and massive root system can also hold the soil particles together, which makes it extremely efficient in preventing soil erosion. Soil erosion is the primary source of airborne lead, which becomes a part of the house dust that children are exposed to more frequently than direct ingestion of soil lead. Reduction in soil erosion by vetiver will reduce particulate matter generation, thereby effectively reducing house dust and lowering blood lead levels. After obtaining remarkable achievement for the laboratory and greenhouse experiments, we applied similar methods to field studies. Those field studies are conducted either in the back or by side of the old buildings. We test how the vetiver grass works for the lead removal in those fields. Actually, in the soil, there are many existing forms of lead, such as chemical or organic bond lead, water-soluble lead, and exchangeable lead, but only the water-soluble and exchangeable lead can be taken up by vetiver grass. To facilitate lead extraction, we applied a biodegradable chelating agent, EDDS, to convert partial of the bond lead to water-soluble and exchangeable forms, which is good for phytoextraction. We also installed leachate collectors in the test fields to prevent potential pollution in the case that excessive lead was converted for vetiver uptake. The field study in San Antonio showed lead concentrations in the soil gradually dropped with the EDDS facilitated phytoremediation, and there was a significant increase in lead uptake by vetiver grass after the application of EDDS, particularly in the roots of vetiver grass. Current field study in Jersey City also offers promising results. The application of EDDS facilitated phytoextraction decreased the total lead concentration in the residential soils by up to 14%, while the lead concentrations in the vetiver roots increased by up to 3 times. These ongoing field studies start to show progresses in lead removal, and the outcomes will provide valuable information and instructions for future studies and applications. Please feel free to contact Dr. Sarkar's Environmental Sustainability Lab if you are interested in more information. Thank you for your time.